Hello there! This video is going to show you one of my favorite analyses because it is just so common and so fun to interpret, and that is correlation. So you're going to use Excel to do a correlation analysis using the regression analysis tools in Excel, and I will also show you in a subsequent video how to make a correlation table and also how to write these things up in APA style. So without any further ado, let's get started. And this time I'm going to have you actually download the entire data set instead of just copying and pasting, because we are going to use several variables in the series of videos from this chapter. So here we go. Let's go to File, whoop, Download, Microsoft Excel. And we'll just grab that file real quick. Okay. We want to enable editing for that. All right, so for the correlations, we are going to be focusing on these kind of pinkish variables. Can't be having that. There we go. And so those are the ones we're going to be working with today. And we're going to start with looking at missed days of class and number of children. So I want to look at the entire class to see if there is a significant relationship such that students who have more children tend to miss more classes. So I'm really expecting a significant positive correlation or relationship between these two variables here. So what I'm going to do, instead of just copying this and pasting it into another tab, I'm going to be more mindful about it, because when we get into our new tab, right, we're going to do a correlation. Whoop. And we always kind of want to just put our analysis and our variables here. So we're going to have missed class. I'm going to abbreviate because you don't have endless characters, and kids. There we go. Okay. So when we put our data into this tab, we want to make sure that our X variable, our predictor, our quasi-independent variable goes here in column A. And we want to make sure that our Y variable, or our dependent variable, or our outcome variable goes here. So in this study, my independent variable, my predictor, really quasi-independent variable because I didn't manipulate it, is number of children. I think that's what comes first. You have kids, they make life a little more difficult, hard to go to class, all right? So I'm going to copy them first. So I'm just going to highlight this whole column by clicking the letter above it, copy, go to my new tab, go over here, and just paste them in. And we'll leave it pretty. Why not? If you don't want to leave it pretty, you can always just paste values and then you don't end up with the background. All right, now let's grab our Y variable, our outcome of interest, missed classes. So we'll copy it, come over here, and we'll paste it in. Okay, so before we actually run the correlation analysis, we need to take a look at the scatter plot to see what's going on there. So let's go ahead and go to highlight our data. So you can just click the columns above to highlight both. Click on Insert, then go to the Charts tools and select the one that looks like a scatter plot. And just go ahead and pick the first one. We don't need lines. Okay, so now let's do some formatting before we talk about what it looks like. So let's get rid of this title. Oh, actually, let's go and do quick layout. That'll get us where we need to be quicker. Layout 1. Cool. So that gives us our axis titles without us having to add them here. All right, so let's get rid of this legend. We don't need it. We can go ahead and get rid of that title as well. And then down here, this is our X variable, this first column of data. So that's going to say number of children. Okay, this over here is our Y-axis corresponding to our Y variable, or our dependent variable, which in this case is missed days of class this semester. So for this, I'm just going to put number of missed classes. Great. All right, my font is not the way I want it, so I'm just going to increase it a little bit. And I'm going to make my font black as well. Cool. So if we take a look at this scatter plot, there's something that really stands out to me. And whenever we're really thinking about strength and direction of relationships, you're kind of like drawing a circle around your dots. And if we draw a circle around our dots, it's kind of fat-ish, right? So it tells us it's moderate, but it has a clear upward direction, right? But that upward direction is primarily driven by this and this, right? So we've got someone in our sample who has 10 children living with them, God help their soul. But we also have somebody who has missed 25 classes. Ooh, they need help too, right? But these are outliers, and you could confirm that with z-scores. If you took the mean and standard deviation of number of children, you would find that 10 is more than 3 standard deviations away from the mean. And it's the same thing, if you took the mean and standard deviation for missed days of classes, you would find that this 25 is more than 3 standard deviations above that mean. So we're going to do the analysis first with the raw data in its natural form, because we want to include those students, right? They matter. But then we're going to run the analysis again, just looking at this cluster of dots down here that doesn't include an outlier, that really represents the trends among most of the students in the class. So let's go ahead and run our correlation analysis by going to the Data Analysis tab. If you don't have that available, make sure you go to File, Options, Add-ins, Analysis Toolpack, and then make sure that you click Go down here. Make sure it's selected, and then click OK. And then you'll have, in the Data tab, Data Analysis ready to go. So let's just click it. We're going to go down to Regression. Okay. And here, if you could run a correlation, but it just gives you the correlation value. It doesn't give you the significance test, so we're going to use the regression option. So here we go. Our Y value is missed days of class. Be careful with this. So we need to put that second column in first. And for this one, you can't just click and highlight the whole column. You physically need to copy all the data. If you're working with a larger data set, you could just click the label and then scroll down over here to the bottom, hold shift and click the bottom, and it'll highlight everything in between. All right. Our X value, our quasi-independent variable, just copy that or highlight that. Labels are in the first row. We don't need to mess with any of this. Output range, we want to put that up here somewhere. So let's just put our output for that right here. All right, and let's click OK. All right, we need to format our values, so let's right click, Format Cells, Number, and let's go 3 decimal places. Okay. We also want to go to the Home tab, go to Format, Autofit Column Width, so we can actually see everything. All right, so as predicted, based on the scatter plot, we do indeed have a moderate positive relationship. Remember, the criteria for a moderate correlation is about a 0.3, and that's where we're at right here. All right, here's your R-squared value if you wanted to look at your effect size as well. So we could say that 13.9% of all the differences in number of missed classes is attributed to the relationship between number of children and number of missed classes. Let's see, what else is really critical? Okay, here is our p-value right there. The significance F, that's the p-value for the correlation. So we can see here that it's 0.008, which is less than 0.05. So we would reject the null hypothesis and say, not only do we have a moderate positive correlation, but it's a significant moderate positive correlation between number of children and number of missed classes. So based on that, we would say that, yeah, students who have more kids tend to miss more class. All right. Also, something that's really weird and that I'm not really in love with Excel. You have to look at both of these values to determine the direction of the correlation. No matter what, even if this was a negative relationship, if we saw a downward slope here, this would still be a positive number. So when you're doing correlation like this, you have to look here to see the sign of your correlation. It's not an issue right now because we have a positive correlation, but if it was negative, this would be a negative number, and that's how you would know that this correlation is also negative. Okay, so now let's go ahead and do the correlation again, but we're going to get rid of the outlier this time. So let's just start from scratch and we'll just steal this data from here. Copy, new tab, and paste. Great. Let's name this correlation, no outliers. Get out of here, outliers. Okay, so the way that Excel works, you cannot run correlation or regression with any missing data. So we have to get rid of all of their data if they have an outlier. at least for, what we're looking at here, the subset of the data. So our first outlier is for missed days of class this semester, and you see the 25 here. So we're just going to get rid of that entire row of data. So we highlight it, right click, and go up to delete. You don't just want to delete it with your keypad because then it'll just leave this blank. And again, correlation and regression won't run if you have missing data. So we don't want to do that. We just want to get rid of it completely. So right click after you've highlighted both and click delete. It'll ask you what you want to do. We want to shift the cells up. Boom, done. All right, down here now is our other outlier, right? So we saw someone with 10 kids and 25 missed classes over here. No good, right? So we just got rid of the person who has missed 25 classes. Now we need to get rid of the data for the person with 10 kids. So you just highlight that, right click, and try again. Highlight that. There we go. Right click and delete. And we want to shift the cells up there. So now you'll see 49 minus 1, we only have 48 rows of data now because we got rid of 2 people from the sample that had outliers. Okay, so now we're ready to do a scatter plot with this to just see what the shape looks like, to kind of figure out what the direction may be and what the strength may be. So we just highlight again, insert, pick the scatter option under charts, click the dots, boom. Format it. We can just go to quick layout. I like layout 1, gets us a good start. Delete, delete. And again, like last time, number of, whoop, if I could spell it right, that would be helpful. There we go, children. And number of missed classes. Great. Let's go ahead and increase the font size just a smidge. Make it black font. All right, great. Now let's go ahead and run the correlation analysis and see what happens now that we've got rid of those outliers. Because if we drew a circle around this data, you would now see that the circle would be kind of like a horizontal circle, right? It no longer has that upward direction to it. And usually when you have a situation where you have dots that are just kind of everywhere and there's not a clear direction, we've got a weak relationship or a weak correlation. But let's prove it. So go to data, data analysis, regression again. Okay. This is almost set up perfectly for us, but we've got some data that's gone, so we can't just kind of do it again. So we actually have to go through and let's highlight just down to now our trimmed data. This is kind of carryover from the last time we ran the regression. Remember, the y variable is going to be the second variable that you have, and the x variable is going to be the first one if you did it correctly. Labels, output range. Sure, we can stick it wherever we stuck it in the last one. And here we go. Boom. Okay. We need to format, right? So right click, format cells, number. We need 3 decimal places because we've got to know our p-value for APA style. And then we can just go ahead and go home, format, and auto fit that width. Wah, wah. Look at that p-value. It's not less than 0.05 anymore. This tells us that there is a 3.98% chance that the observed, oh no, even worse, 39.8% chance that any observed trend, any relationship here is really just some sort of fluke due to noise in our data. It's not due to a true relationship between those values. Here, we only had a 0.8% chance that the observed relationship was due to a fluke. Here, 39.8% chance. So we're not going to call that significant. We can't reject that in all. Look at this. It became weak, right? The correlation is now 0.125. Any correlation around 0.1 is considered weak. So it's not moderate anymore. It's weak, as we suspected based on the way that the scatter plot looks. And it is also no longer significant. And of course, it's still positive. All right, so I hope that this video helped you not only learn how to do correlation and test the hypothesis about correlation and do scatter plots in Excel, but also to think really critically about the impact of just a couple of outliers on the results of a statistical analysis with correlation. So if you are ever trying to be convinced with correlational data, maybe ask to see that scatter plot.